So I thought a fun place to start would be to go back a little bit in history, because this is so relevant to frame the conversation. You started LiveKit initially as a company for humans to talk to other humans, Google Meet and Zoom competitor using WebRTC. When was the moment when you realized that you could use that platform for humans to talk to AI?
Yeah, so LiveKit started very different time in the world. It was a pandemic. You were stuck at home. Only way to talk to people was over the internet. And so the way that you did that was you used like Google Meet and Zoom and Discord. There were a few other apps, but those were the main ones. And the reason you used them was because they were built for streaming audio and video at scale. The rest of the internet wasn't built for that purpose. Most of the web is built on something called HTTP, which I'm sure most people here are engineers, or you've at least typed that into your browser, stands for Hypertext Transfer Protocol, not Hypervoice or Hypervideo. And so it turns out there's another protocol that was built for that purpose, for transferring audio and video, called WebRTC. It had been in browsers, Chromium, since like 2011. And it had been kind of in relative obscurity for a long time. It hadn't been used largely outside of like Blue Jeans and Zoom. And so, you know, during the pandemic, everybody's trying to integrate audio and video into their application. And I was a developer trying to do that, and I needed audio and video infrastructure. And I immediately kind of went and said, okay, well, what's an open source? And turns out there was nothing. So if you wanted to integrate those features, you were either stuck using a really expensive commercial offering, or you kind of made it a Zoom screen share, right? You didn't have that feature natively baked into your app. And so started to work on infrastructure to support a side project for audio streaming. Side project turned out to be not a great idea, but put out the open source infrastructure in the summer of 2021, called it LiveKit. And it just started to explode and had lots of large companies starting to use it. And when we went and talked to them, asked them why, they said, well, you would be surprised. Even the commercial offerings can't deliver on the 3 core tenets of infrastructure, which is 5 nines of reliability, the lowest latency possible through an edge network, and massive horizontal scale. So they said, if you guys can build a infrastructure around your open source offering that can do those 3 things, we'll happily buy it from you, and use it as a cloud service. And so we started to work on that. We raised a round and started a company and worked on this thing called LiveKit Cloud. So LiveKit Cloud is this globally distributed edge network of media servers all around the world, and delivers on 5 nines of reliability, the lowest latency possible through an edge network. So every user is connecting at the edge and then streaming all of their media over the private internet backbone. And then you can keep spinning up servers and servers and servers, or we can, adding it to this kind of mesh network fabric. All these servers intercommunicate with one another. Spent about 2 years working on it, launched it at the end of 2022, and then ChatGPT comes out at the end of 2022, and I was using it, and I'm like, man, GPT-2 was just so terrible, and now 3.5 wrapped in an app, it's like so good. But what if you took LiveKit's infrastructure, WebRTC, you pair that with ChatGPT, could you create a computer that you could talk to instead of just text with? So we worked on a demo, and we kind of built Samantha from her as a demo, and we launched it a few months later, or posted it a few months later on X, and we were like, we're for sure going viral. And then I think we only got like 100 likes on it. Nobody noticed, but 5 months later, OpenAI ended up finding the demo, reading the blog post about how we built it, and then they signed up for LiveKit Cloud in secret.
Yeah, exactly. That was kind of secret for a while, right?
Yeah. It was a secret for a while for a couple of reasons. One, it was a very new use case that we'd never imagined. But 2, it's OpenAI, so we can't talk about it either. Now we can, but yeah, that was the moment where I think we realized that we had originally built this infrastructure to connect humans to other humans around the world during the pandemic. But as the AI model becomes more like a human, you can take one of those humans out, and now you can put in the machine, and the same infrastructure can be used for giving a machine the ability to see, hear, and speak back to you.
Yeah, so actually it's a perfect example. Let's use ChatGPT voice as an example. How does that work beneath the surface in terms of like what you guys power? How does something like that actually work?
Yeah, so I think that, so WebRTC is a peer-to-peer protocol. That's how it was originally built. And what that means is it was a protocol designed for a human-powered device to talk to another, or a human-operated device to talk to another human-operated device. So I want a video conference with you or FaceTime with you, and I'm on my phone and you're on your phone. Someone's on a desktop computer trying to talk to me, and I'm on another device. But it was meant for humans to use these devices to talk to one another. What OpenAI wanted to do with voice mode is they wanted to actually have a human talk to an AI model on the back end. And WebRTC by itself was not designed for a server program to use that protocol. And so what we had at the time was we had this SDK in Python that allowed you to use WebRTC from a computer program. So that computer program, you could write the code, it could consume audio and video streaming in from a device, and it could also generate and stream back out audio and video. And so that was the original kind of thing that OpenAI took and we started to work with them on this feature. And the way it works is this, is that like you have a LiveKit SDK on a client device. So if you have ChatGPT installed, you probably have a LiveKit client SDK sitting on your phone right now. And when you tap on the voice mode button, what's happening is that your phone is connecting to LiveKit's cloud network. So our data centers all around the world. Also sitting in those data centers is an agent, right? At that time, it wasn't called a voice agent, but now that's the kind of the parlance that we use. But a voice agent is really a computer program that is ready to get into kind of like a Zoom call with you. So they're sitting in a pool and waiting for somebody to call in. You tap on the button, you're now connected to LiveKit's cloud, and the agent is also connected to LiveKit's cloud. And what's happening is the system is pairing you with that user who wants to talk to that agent, or pairing the user who wants to talk to that agent. And so you speak into your phone, your microphone is capturing the vibrations in the air, turning that into binary data, sending it over LiveKit's network where it arrives on the agent side. The agent then takes that audio and processes it. So depending on how you have configured that program on the back end, the original version of voice mode, to use that as an example, would take that audio streaming in, it would convert it into text from speech using an AI model. Then it would take that text, pipe it into an LLM, right? The LLM then spits out tokens, text tokens. You're taking those tokens, you're converting them back into speech using a text-to-speech model, and then you're streaming it back over LiveKit's network, and you're playing out that audio on the device. And so that's happening over and over. Every single turn is going through this process.
And to the title of this conversation and why the cloud infrastructure was not designed for our current moment, is a fundamental difference behind all of this the concept of stateless versus stateful, and unpack what that means in technical terms?
Yeah, so when we first went to go put voice mode out there, like launch it, you know, we met with OpenAI, and the question came up, well, how should we like deploy and scale voice mode? It's a little bit different from the way that ChatGPT, you know, chat works. And that's because for an AI agent that you can talk to with this natural human interface and can talk back to you, that you can interrupt and it detects when you're done speaking and all of these types of things, that's a very different kind of runtime process or architecture than a traditional web application. So traditional web application, you establish a connection to a server from your client, you send some data, right? Business logic runs, and then server sends back some updated state to your client, and then your client renders it. And the connection between the client and the server is severed. And that works fine for chat, because like when you're chatting, you send a message, you don't expect like the AI to respond immediately, right? Like, nor do you expect a human. Your prior for like chatting in an SMS or like iMessage is not that you're gonna see the typing indicator immediately and get a response immediately, but your prior for speaking to something or someone is that they're going to talk back immediately, right? You're not going to have to wait 5 seconds to hear a response from them, typically. And so what's happening with a voice agent is that voice agent is constantly streaming in audio, right? Figuring out whether you're interrupting it, figuring out whether you're done speaking or sharing your ideas or thoughts with it. It's also thinking as well, especially with the reasoning models now. That's a constant process that's happening. And then it's also responding at the same time. So it's doing these 3 things kind of continuously, right? You can't have a connection model, and context is being built up on both sides as well. That model has a memory, you have a memory, and like there's this statefulness to it, right? Like you remember what you talked about 30 seconds ago, 5 minutes ago, and you might return to a topic, right? And the AI is kind of doing the same thing. And so that's a stateful session. It runs for 5 minutes, an hour, et cetera. It's like an indeterminate amount of time where it's constantly processing data. You can't load balance and scale something like that the same way you would a web application where you can just round robin requests across web servers and all the requests are roughly uniform in their workload. And so it's just it's a complete paradigm shift from how you kind of deploy and scale these types of things.
So what does that mean in terms of core primitive? You're effectively building an AWS-like, right, for AI. So if you think of the core primitives of cloud to be compute, storage, and networking, what are the primitives of the agentic platform of the future?
Yeah, so I think the big learning from that initial use case with OpenAI was that when you shift the input, right, the I/O, from a keyboard and a mouse to cameras and a microphone and a speaker, that's kind of like the tip of this iceberg, right? Like it's like, oh, okay, the input's changed, right? The way I interact with this computer changes. But underneath, like, it turns out that all of the architecture has to change completely. So we've built web applications. I mean, all of y'all are probably familiar with like the software development lifecycle, right? You got to build things, you got to test things, deploy, scale them up, observe them. It turns out that for voice AI, you have to reimagine everything from the ground up. You can't build that application the same way, which we just talked about how it's built, right? It's a different type of backend from a web backend, a traditional web server. You can't test it the same way. These models are stochastic, right? They're talking to you. You don't know whether they're going to go off the rails, what they're going to say, et cetera, whether a particular tool gets called. So you can't test it the same way. You can't deploy it the same way. So like load balancing and scaling a voice agent looks more like scaling a multiplayer video game than it does a traditional web app. And so that's also new and has to be rethought. You can't like run and scale it. The network infrastructure, which I kind of mentioned at the start, is fundamentally different. Like you can't even use the same protocols as the traditional web uses. And then you can't observe the same way either, right? For a voice agent, you have to have a full breakdown of that session. You have to understand, what did the agent say? What did the user say? Did the agent call this tool? Like if I like say if I'm talking to like a healthcare agent and I say the name of a drug, what did that agent hear? Did it actually get the right thing? And like, you need to kind of have this full breakdown to understand what happened in that conversation and leverage those insights to kind of pipe back into your build and test phase so you can improve on your agent and hopefully solve some of those problems or bugs that you see in production. And so the entire, we call it the agent development lifecycle, has to change and the infrastructure to support it. And so while we're not like providing raw compute and raw storage and raw network, we are providing those things, but a layer up the stack, right? So what we're building is really this end-to-end system that allows you to build, test, deploy, run, scale, observe voice agents, video agents, physical AI agents, those kinds of things. It's like all the different pieces that you need, not just like the raw resources.
Yeah, great. Let's unpack some of it. You mentioned observe, and in some ways what you're building is the data dog for AI. So very much to your point of a second ago, those are stochastic systems, very hard to understand. What's the reality of how you observe how a voice AI agent acts?
Yeah, so I think like so testing, eval, simulation, and observability are kind of closely connected pieces and both really critical for getting these kinds of voice AI applications into production at scale where even large companies feel very comfortable scaling them up. And so observability is the first part that's really important, and testing is kind of like has a dependency on observability because you need to know the outcome of tests and see what happened in a simulation. So you got to build that piece first. So like observability, it's really the full breakdown of a session, right? You want to be able to see a full transcript, but not only that, you also want to be able to go in and like replay like the call itself. You want to see what the user said or hear what the user said, hear what the agent said. If that agent is like manipulating tools, like let's say that it's going and taking an action in a browser, you need to be able to see like, okay, well the agent opened this browser instance and here's the page that it opened and here's what it clicked on and all of this stuff. So you need to really understand what that agent is doing, right, in that call. Why that's difficult is it's difficult for two reasons. I think it's difficult in that there's just so much data being generated in real time. And then how do you also visualize it or display it to the user in real time? You can imagine that like with infrastructure, one of the things that's critical for people is when is it broken, right? Infrastructure has an expectation that it's always going to work. You need to be able to very quickly index that information as it's coming in. It's audio and video, so it's data dense. You have to index it or process it, and then you have to make it searchable and have people be able to look up or tag or slice the data very quickly. So that's a really challenging thing to build. And so we've been, when we first had our analytics or observability product internally, and then like OpenAI turned on ChatGPT voice, like we did not anticipate that kind of level of scale. So we spent about a year and we had to rewrite everything to really architect it for scale. And so that was a really challenging piece. We launched the kind of full observability stack a few months ago, late last year. And then the other part is kind of testing these things, right? So they're stochastic, and you can't test them the same way you test traditional software. So traditional software, you have to write assertions, and these things are like deterministic, code execution to make sure a particular thing happened. These things you have to test like almost like you test human beings. Like human beings like go to college and get a degree, and they have a resume and a job interview, and you do reference checks. And what you're really trying to do is build a statistical confidence that like this person you're hiring is going to be able to do a task that you want to hire them for, with 99.99% kind of precision or confidence. And like you have to test agents in the same way, and that's through simulation. So you run thousands and thousands and thousands of these kind of like end-to-end simulations where you permute like the accent or the language or like the maybe even the system prompt or et cetera, the instructions that you're giving the agent. And then you see how it performs against some success criteria that gets spit out of your observability stack. And so that's the connective tissue between the two. And so what you're doing is you're building confidence, deploying it, observing it, and then you see bugs, insights, issues that require tweaking, and then you take those things back and you make a change to your agent code, test it again, run simulations again, make sure there's no regression, but also test for this new thing that you discovered in production, deploy again, scale again, observe again, and that's how the loop kind of goes.
Fascinating. As a VC, as I listen to you, I can't help thinking what is left at the upper layer, at the application layer. So if a lot of the intelligence is at the model layer, and then that includes the reasoning, but also the voice to TTS and speech to text. And then you guys on top do all the engineering and what sounds like guardrails as well. Then what do people can you build a company on top of this? What is left? Are you just a go-to-market machine that's completely run by the underlying models in LiveKit?
Well, I think I think the go-to-market machine becomes really important in like the world of cloud code getting better and better, right? We were just talking about this the other day on my team about, well, like it's interesting. Maybe every product can be like replicated in in a week or something like that, and so the differentiator becomes like, how do you actually sell and market that product? But that's beside the point. Like what we seek to do is you have like, we think of LLMs as like this raw material, right? Intelligence is kind of like electricity in a lot of ways. And you need a harness around it to be able to use that particular raw resource, right? So you have like electricity and you have PG&E, in California anyway. And so, you know, we think of ourselves as building all the infrastructure around the LLM so that you can build applications easily on top, right? What we go to solve is we seek to solve undifferentiated problems. So we're not trying to solve, you know, there are specific workflows to use examples, like LiveKit is used a lot in healthcare, in retail, in FinServe, and all these different industries. But these industries have vastly different applications, and there are certain workflows that are bespoke to that industry, like doing like a wire confirmation is very different from doing patient intake at a hospital. And that is the concern of like the application developer or like the expert within a domain. For us, there is a common denominator of infrastructure problems, you know, mapping underneath to storage, compute, and network that people without something like LiveKit would have to solve over and over and over and over. And so what we're doing is solving it one time, making it flexible enough that it can be used in all of these different use cases, but then the developer gets to focus on the use case and making sure that that UX is incredible. And so, yeah, I think there's plenty of room to build stuff. Well, we're not taking everything away.
Great. Maybe to close and to make it very practical for AI builders and founders. So you had your evolution that we started with at the beginning of this conversation. Today, how do you navigate this just never-ending flow of like information and changes? And this market is so dynamic, and there's something new like quite literally every few seconds. How do you build in such a noisy and dynamic environment?
It's a good question. You know, I think like there's a version of this question which I'll kind of like apply specifically to what we do in voice AI and like developers who are building applications in voice AI. One question that comes up a lot is, well, should I like build kind of these hacks or workarounds on the current model, right, and its capabilities, or should I just kind of build the thing that I know is coming, right? And the recommendation that I always have is AI is on such an incredibly crazy kind of like ramp that the thing that you're anticipating is going to happen down the road is going to happen down the road in 6 months, right? It's not that far away. And by the time you figure out all the other parts of like the product you're building and the company you're building around it, the technology that you need at the layer below is already going to be there. So really build towards that. I think that there's certainly a lot of noise, but I would pay attention to more of like the broader strokes, right? Like, and I also, for myself personally, when I think about where the tech is going, I draw analogies to like human beings a lot as well. Like that's ultimately what we're trying to build with all of this AI stuff. We're trying to build ourselves in a lot of ways. And I don't personally think that the current architecture of LLMs is going to get us there, but it's going to generate insane economic value nonetheless, right? Because you can like any task that you know, has a kind of a recipe that humans are able to do, this thing can like learn how to do that. And so you can automate all work, I think, over time, even just with the architecture we have today. But yeah, I like think building like 6 months ahead of where you are now is what I would say is the most prudent thing I could recommend. But it's noisy for sure.
Great. Russ, thank you so much.
Thanks so much for having me.